Hello friends, welcome back to STM tutorials. Myself Ajinkya and we are here to learn more about STM controller. So let's begin. In this video, we will learn how to interface relay with STM32 controller. So go on to File, click on New, click on STM32 project. It will initialize the target selector. In the MCU selector, here in part number, write STM32F103 C6. Click on LQFP48 package, click on next, give project name as relay interface, click on finish. Now here in the pinout and configuration, click on system core, click on RCC, click on HSC, select crystal ceramic oscillator, resonator. Now click on PA0, click on GPIO analog, here analog, go into ADC channel 1. Here in analog, click on ADC, click on IN0. So the PA0 pin is selected as ADC1 IN0, that is ADC1 channel 1. Now click on PA1, click on GPI output. Now click on connectivity, click on USART 1. In the mode, select asynchronous, select baud rate as 9600. Here you can see that PA9 and PA10 pin is selected as TX and RX. Now go into clock configuration. You can see the input clock frequency as 8 MHz. Select HSC. Select PLL clock source. Now in the PLL, select multiplier as 9. So the maximum clock is set to 72 MHz. Now in the APB1 prescaler, select divide by 2, and in ADC prescaler, select divide by 6. So there will be no clock violations. Now go into pinout and configuration and click on generate code. In the while one, here in the while one, we have to write our main program. Now let's go to our circuit. So we have selected STM32 F103 C6 controller. To pin PA0, we have collected LM35 temperature sensor. We have given power input as 3.3 volt and the output is connected to PA0. Now for the relay interface, we are using PA1 pin as GPIO output. So take one relay, connect diode in reverse configuration. This diode will act as freewheeling diode. Now take BC547 transistor. This is NPN transistor. BC547 NPN transistor. Connect collector of transistor to relay coil and another end of relay coil to DC power supply. We have set the DC power supply to 5 volt and connect emitter of the transistor to ground. Now connect PA1 port through resistor to base of the transistor. Here take another supply of 12 volts. Connect it to normally open terminal of the relay. Now connect common terminal of the relay to lamp. Connect second terminal of the lamp to the ground. The lamp operates on 12 volt. So that's why we have given 12 volt supply. Now what we will do is when the temperature is about 28 degrees Celsius, we will turn on the lamp. You can connect fan here. Now let's go to our code. We will copy our code from previously generated project. So copy, go into while one, paste it here. Now initially we will turn on the lamp. So we will use this function. Here before while one loop, we will set the GPIO pin 1 to logic 1. Now save, go to properties, settings, build steps, copy, cancel, close, copy it here, apply and close. Now build the program. See if there are any errors or not. If there are no errors and the hex file is generated, load that hex file into our controller. Now we have 5 errors. Let's see what these errors are. Okay, we have not defined the ADC variable. So u int 16 underscore t ADC underscore val1. ADC val temp. Temp1. Now we have 0 errors. Now go into your simulation, double click on the controller, select the hex file, click on OK. Now you have to change the configuration a little bit. Connect one external pull-up resistor to the base of the transistor with the VCC. Load the X file. Load the X file. Click on open. Click on OK. Now click on run. Now here you can see that the lamp is glowing. Now we will change the program to operate the lamp based on the temperature. So when the temperature is above 28 degrees Celsius, the lamp will be on, and when the temperature is below 28 degrees Celsius, the lamp will be off. Or we can do the reverse of the configuration. Now we will modify our program to operate the lamp when the temperature is below 28 degrees Celsius and to turn off the lamp when the temperature is above 28 degrees Celsius. Now go to your program. Write if temp1 is less than 28, copy this, else make it reset. So when the temperature is below 28 degrees Celsius, the lamp will be on. When it is higher than 28 degrees Celsius, the lamp will be off. So this will make that when the temperature drops below 28 degrees Celsius, the halogen light will be on. When temperature rises above 28 degrees Celsius, the halogen light will be off. Now save the program, build the program, check that if there are any error or not. Now, now load the hex file and click on run. So initially the lamp is on till we get the temperature. When the temperature is above 28 degrees Celsius, the lamp is off, halogen lamp is off. As soon as the temperature drops below 28 degrees Celsius, the lamp turns on. So the halogen lamp will heat up the room. You can connect 230 volt AC supply and air heater to the relay and the same program can work. Now let's go and look into our coding. So here in the while one loop, we have started the ADC peripheral. Now in the second line, we have given the SOC signal that we have asked for the pole for conversion. Then once the conversion is completed, we read the ADC value and we stop the ADC peripheral. Now, now we have read the ADC value. Now we have to convert it into temperature. So we have passed the ADC value. Then here we have taken variable 1, variable 2. Variable 2 is not used, we can remove that. So whatever ADC value we are getting, we have multiplied it by 8.05 and we have written that value. Now we have printed the same value on the wizard terminal. Now in the next line we have printed temp string on the wizard, and then after the temp string we have printed the temperature. So for printing the temperature value, we have used the simple program that to pass the value, then divided by modulo 10, we will get a reminder. Add 48 to it to convert it into ASCII value. Then divide the number by 10, store it into the same number. Then decrement the I. If I equals to 3 means we will get 0, 0, and after that we needed a decimal pointer. So after the two values are stored, we have to store the decimal pointer. So when I equals to 3, we have stored decimal pointer. Now we have converted the whole temperature value into the string, and we have printed the same string on the user terminal. Now build the program. Go into a Proteus file, load the hex value, load the hex file, click on OK, and click on run. Now here you can see that on the user terminal, temperature is printed along with the temperature value. And if the temperature is about 24 degrees Celsius, the lamp will be off. When the temperature is below 24 degrees Celsius, the lamp will be on. So as soon as the temperature drops below 24 degrees Celsius, the lamp turns on. This is it for the video. Hope you enjoy the video. If you enjoy the video, click on like, share and subscribe. Thanks for watching the video. We will see you in the next video.